let's start always from differentiating this. So my substitution is x is sine theta. Let me now differentiate this with respect to theta. So on your left-hand side, we get dx d theta. On the right, we will get cosine theta when you differentiate sine. That's step one. Let's come to this equation. We do step two to replace. So I want to change all the x to sine. Remember to change the dx, but you are not supposed to present. What are we not supposed to present is this line that I write in red here. You are supposed to have dx, the subject. Think of it like a replacement. That's easier for you. So you replace to cosine theta d theta. There will be several important trigo identities that we may want to apply. One of it is here. 1 minus sine square, we should be clear. Let me just write the identities that we want here. Sine square plus cos square is 1. And it's common that you have this kind of 1 minus sine square or cos square. So let's make that change. So 1 minus sine square will give me cos square. My cosine theta stays on the right. Square root cos squared can have cancellation, root and the square. So you have cosine, cosine, they further cancel out. Which means that this equation, we will end up with integration of sine squared. Sine squared integration is not something that you will know how to integrate, but from secondary school, we should know we can convert identity. Let me write more identities on the right-hand side. Your cosine 2 theta is 1 minus sine square. 1 minus 2 sine square theta. Available in the formula list also. Okay, so no need to memorize. Cosine 2 theta is this. You must change your sine square. Okay, we must make sine square the subject. So I will get cos 2 theta 1 minus cos 2 theta over 2. So with that, we will take this equation. You want to put it back to your equation over here. There is this half as a coefficient, so can I move it outside? We still have your 1 minus cos 2 theta. Let's integrate. When you integrate 1, you get theta. Now, trigo, you may need to refer to the front if you had forgotten, but if you integrate cosine, we will get sine. The 2 theta, you must still handle it. If you differentiate, you will multiply 2. Integrate is the opposite process, so you divide by 2. Differentiate trigo, you multiply 2. So integrate trigo, you divide by 2. Okay, plus C at the back. We have done the integration. What is the last step? Last step is to change all the u back into an x. So in this case, is to change theta back into x. So how to change that? The first term is straightforward. Theta, you don't have a choice. If x is sine theta, then what is theta? Theta would be sine inverse x. We move the inverse trigo over to the other side. So here I get sine inverse x. But you need to know that the following is incorrect. I should write it for you here so that you don't make that mistake. It's wrong for you to now change and say that this theta we write as sine inverse x like this. This format is considered not simplified. So you will lose marks for it. It's as though you didn't convert back to x. Okay, do not write something like that. If it's a double angle 2 theta, you don't want to make the conversion look like this. Don't do sine inverse. If you have trigo, don't just do sine inverse. So what you should do is, can we open up with double angle formula? Sine 2 theta is 2 sine theta cos theta. It will create a cancellation. Okay, so let's finish up on that last line. How can we change back into x? Sine theta is clear. Sine theta is x. So your first trigo here, we will write as x. Cosine theta, we will need a triangle to try to solve. What do I mean by a triangle? Our sine theta is x. So sine theta, can you view it as is x over 1? How do we go from a sine to a cosine? We will need to go for a right angle triangle. This is your angle. Opposite over hypotenuse is x over 1. Think of a right angle triangle. Opposite over hypotenuse. So the last length below will be 1 square minus x square if we do Pythagoras theorem, square root. Okay, 1 square minus x square, square root will give you the last side. So I can write down what is cosine. Cosine is adjacent over hypotenuse, so we will get this over 1. We take that value, we put it back to your trigo. Plus C. So what is important and different with the above example that I need you to highlight or understand is, if you have got a trigo substitution, very likely at one of the parts, you will need to draw a right angle triangle to simplify certain terms.